Dear students, Assalamu alaikum. I am Professor Naveed, Department of Physics, GC Okada. Today I will start the lecture for ADS, Associate Degree in Science, and I am going to teach you force and Newton laws of motion. First of all, description of motion. Description of motion को हम आज समझेंगे सबसे स्टार्ट में। तो हम सपोज करते हैं कि ये एक वायर है डियर स्टूडेंट्स, और इसमें एक दिस इज वायर। हमारे पास एक बीड है जो इसके अंदर मौजूद है, जो इसमें वर्टिकली स्लाइड कर सकता है। सो दिस इज नोन एज बीड। सो इन टर्म्स ऑफ ग्राफिकल रिप्रेजेंटेशन अलोंग द एक्स एक्सिस हमारे पास टाइम इंटरवल है रिप्रेजेंटेड बाय टी। वर्टिकली डिस्प्लेसमेंट है represented by x, and this is the origin. Now bead is at rest. Bead is at rest. So at position A, so x is equal to A, and we can say, हम ये कह सकते हैं कि ये बीड कहाँ पर मौजूद है? रेस्ट में मौजूद है एट द एक्स कोऑर्डिनेट A. सो अगर रिजल्ट की सूरत में देखें तो हम क्या लिखेंगे? The bead is at rest. The bead is at rest at the x coordinate A. At the x coordinate A. Now in case number 2, bead slide कर जाता है। बीड की स्लाइडिंग वायर मौजूद है जैसा कि हमने पहले आपको बताया, और डिस्प्लेसमेंट इज इक्वल टू 0 है। बीड अपवर्ड मूव कर जाता है, बीड अपनी पोजीशन को चेंज करता है। तो इसकी ग्राफिकल सिचुएशन डियर स्टूडेंट्स कैसे बनाई जाएगी? कुछ इस तरह से होगी। द बीड इज मूविंग with constant speed b, and its equation of straight line is x is equal to a plus bt. B is constant speed, t is the time interval, a is the coordinate. So this is the case for uniform motion. This is the case of rest. This is the case of a bead moving with uniform velocity. Moving with uniform velocity. If now suppose the bead is moving with an acceleration a, bead is moving with acceleration a, bead move upwards but with an acceleration a. Now its graphical representation will be like that. So this shows that bead is moving with an acceleration a, and here is the time interval, and it is moving with acceleration. It is moving with an acceleration represented by a. Now lastly, if a bead oscillates between 2 points, bead oscillates between 2 points, meaning up and down motion, so its graphical representation will be like that. It swings between points plus a and minus a, and this is the 0 point, and this is the time interval. So swings bead swings between 2 points, and it oscillates between x is equal to plus a and x is equal to minus a. तो इससे हमने ये समझा कि बॉडी रेस्ट में, हमने एक एग्जांपल कंसीडर की, उसके बाद हमने ये देखा कि बॉडी या बीड रेस्ट में हो तो क्या होता है। यूनिफॉर्म वेलोसिटी के लिए स्ट्रेट लाइन की इक्वेशन डील करेगी। दिस इज अ स्ट्रेट लाइन, दिस इज द इक्वेशन ऑफ ए स्ट्रेट लाइन। A bead moving with an acceleration a and if it swings between two positions plus a and माइनस ए। तो डियर स्टूडेंट्स, इसके बाद हम ये देखते हैं, न्यूटन के लॉज को देखते हैं, और न्यूटन के लॉज से पहले हम फ्रेम्स ऑफ रेफरेंस को डील करते हैं। सो आवर नेक्स्ट पॉइंट इज फ्रेम्स ऑफ रेफरेंस। डियर स्टूडेंट्स, आपने ये पहले भी पढ़ा होगा, जस्ट फॉर your go through frames of reference. What do you mean by frames of a reference? Frames of reference. So dear students, a set of coordinate axes, a set of coordinate axes attached to a certain object, attached to a certain object is called frames of reference, is called frame of reference. Dear students, as you can know, this frame of reference is usually represented by three mutually perpendicular lines: x-axis, y-axis and z-axis. So this is the frame of reference. So there are two types of frames of reference: inertial frames of reference, non-inertial frame of reference. Inertial frame of reference and non-inertial frame of reference. Non-inertial frame of reference. Definition मैं ये बता दूंगा. Inertial frame of reference, a frame of reference in which a body will moving with uniform velocity. इसमें क्या होता है बेटा? A body is at rest, a body is at rest or moving with uniform velocity. For those bodies or particles, we deal with inertial frame of reference. If bodies or particle moves with an acceleration, the frame of reference which has non-uniform motion or accelerated motion is known as non-inertial frames of reference. So dear students, आप ये देख रहे हैं कि जो बॉडी रेस्ट में होगी या यूनिफॉर्म वेलोसिटी से मूव करेगी, हम उनको डील करवाते हैं इनर्शियल फ्रेम ऑफ रेफरेंस में। और नॉन इनर्शियल फ्रेम ऑफ रेफरेंस में कौन सी बॉडीज़? जिनकी भी एक्सेलरेशन मौजूद। फॉर एग्जांपल, एक कार ब्रेक अप्लाई करती है तो इसमें डी एक्सेलरेशन प्रोड्यूस होगी, तो ये नॉन इनर्शियल फ्रेम ऑफ रेफरेंस में है। अगर आप बाइक पर मूव कर रहे हैं यूनिफॉर्म वेलोसिटी के साथ, यू आर इन ए inertial frame of reference. Newton laws of physics are valid. Newton laws are valid. Newton laws are valid in inertial frame of reference, whereas Newton laws of physics are not valid. Newton laws of physics, Newton laws of physics are not valid in non-inertial frame of reference. So this is the idea about the frame of reference. Now we move forward and Newton laws of motion. Newton's laws of motion, Newton's first law of motion. Dear students, definition is very simple. If a body is at rest or moving with uniform velocity, if a body is at rest or moving with uniform velocity, it will continue to do so unless an external force applied on it. यूनिफॉर्म वेलोसिटी मीन्स मोशन. अगर एक बॉडी रेस्ट में है, हमेशा रेस्ट में ही रहेगी. दिस इज वेरी सिंपल. बट इफ a body is moving with uniform velocity, it will remain in motion unless an external force applied on it. So this is known as Newton's first law of motion. Suppose a book lying on a table, a book lying on a table remain there unless an external force apply on it. So this is the first point. Second point is about motion. A ball, when you apply force on it, इट विल मूव इन द फॉरवर्ड डायरेक्शन. ये फॉरवर्ड डायरेक्शन में मूव करेगी. लेकिन इसे तो रुकना ही नहीं चाहिए, इसे तो हमेशा ही मूव करते रहना चाहिए. तो फिर ये कैसे स्टॉप कर जाती है? इट इज़ बिकॉज ऑफ द टर्म नेम एज फ्रिक्शन. अगर हम इस फ्रिक्शन को ज़ीरो कर दें तो ये मूव करती रहेगी. तो न्यूटन का फर्स्ट लॉ हमें ये डील करता है कि कोई भी बॉडी ऑटोमेटिकली फोर्स अप्लाई करें तो हमेशा मूव नहीं कर सकती, वो रुक जाएगी, स्टॉप कर जाएगी. इट इज़ ऑल बिकॉज ऑफ फ्रिक्शन एंड इनर्शिया. सो न्यूटन फर्स्ट लॉ के साथ हम इनर्शिया को भी देखते हैं. इनर्शिया क्या चीज़ होती है? सो दिस इज द न्यू टर्म इनर्शिया. द प्रॉपर्टी ऑफ एन ऑब्जेक्ट. डेफिनेशन में बता रहा हूँ, लिखने में टाइम लगेगा. डेफिनेशन क्या है? द प्रॉपर्टी ऑफ एन ऑब्जेक्ट that tends to maintain the state of rest. क्या करना है? maintain करना है. किस चीज़ को maintain करना है? state of rest or of uniform motion. or of uniform motion is known as inertia. एक दफ़ा फिर definition देखें dear students. The property of an object that tends to maintain the state of rest or uniform motion is called inertia. Inertia is its main point. Inertia of a body is directly proportional to mass of a body. Is directly proportional to mass of a body. Dear students, truck has greater mass, so it has greater inertia. A bicycle has smaller mass, so it has smaller inertia. Now, dear students, moving forward to Newton's second law of motion. Newton's second law. Newton's second law, dear students, very easy. आप इसको पहले भी डील कराए हैं. What is the statement? A force applied on a body produces acceleration in it. This acceleration is directly proportional to force and inversely proportional to mass of a body. So this is equation number 1 and equation number 2. Acceleration is directly proportional to force. Greater the force, greater will be the acceleration. Smaller the force, smaller will be the acceleration. Now, acceleration is inversely proportional to mass. Mass of a truck is very large, so its acceleration is smaller, and vice versa. Combining two equations, acceleration is directly proportional to force, inversely proportional to mass. So A is proportional to F over M. जब हम इसको कांस्टेंट में लेकर आएंगे डियर स्टूडेंट्स, A is equal to constant, it is represented by K and multiply by F over M. For simplicity, constant is equal to 1, so A is equal to F over M. M cross multiply, MA is equal to F, or F is equal to MA. This is known as Newton's second law of motion. F is equal to MA. Dear students, as you can know that force is a vector quantity. Its unit is Newton. The unit of force is Newton. named after a scientist, represented by capital N. 1 Newton. Define 1 Newton. Define 1 Newton. Define 1 Newton. The force which produces an acceleration of 1 meter per second square. The force which produces an acceleration of 1 meter per second square in a body of mass 1 kilogram. In a body of mass 1 kilogram is known as 1 Newton. Definition बेटा आप खुद लिखेंगे, मैं सिर्फ आपको यहाँ समझा रहा हूँ. So 1 Newton is equal to 1 kilogram meter per second square. This is represented by a capital letter N. So the dimension of force is dimension. Dimension डायरेक्ट ही हम लिखेंगे यहाँ पर. The dimension of force is kilogram, mass m, meter capital L, second की power -2, t -2, ml t की power -2. This is known as the dimension of force. So in the end of the topic, Newton's third law. Newton's third law. For every action of a force, there is always equal and opposite reaction. To every action of a force, there is always equal and opposite reaction. Equal and opposite reaction. So many examples can be taken. We can take some examples. Example number 1, propulsion of a rocket. Rocket moves gas rocket moves in the upward direction because gases are ejected in the downward direction. So this is an example of action and a reaction. A book lying on a table. Example number 2. A book lying on a table is also an example of Newton's third law. Weight is acting in the downward direction, whereas normal force is acting in the upward direction. Weight is in the downward direction, force is in the upward direction. Our walking on the ground. Example number 3. Walking on the ground is also an example of Newton's third law. In our daily life, when we walk, we exert a force on the ground backward. When we walk, we exert a force on the ground backward. This is called action. But this force cannot produce acceleration. In return, ground exert a force on us forward. This force is called reaction of the ground. Due to this reactionary force, we move forward. So many other examples can be taken. Bullet fired from a gun. Bullet fired from a gun. Bullet moves in the forward direction, whereas gun recoils. Gun recoils in the backward direction. Flying of birds. Flying of birds is also an example of Newton's third law. So, dear students, motion of a robot, motion of a robot in a river or a canal is also an example of Newton's third law. So, dear students, today we learned about description of force, Newton laws, first law, second law, third law, inertia, and force. I hope you understand all my lecture. That's all for today. Allah Hafiz.